Hello students, today we are going to discuss about the important topic vestigial sideband transmission. This also comes under first unit amplitude modulation and the course outcome is distinguish various AM communication systems. What is vestigial sideband modulation? One of the sideband is partially suppressed and vestige, that is portion of the other sideband, is transmitted. This portion compensates the suppression of the sideband. This is called as vestigial sideband. In other words, vestigial or portion of sideband means, say for example, a very low frequency signal, like we are transmitting some video signals. So the voice message in the video signal may be very low, but we cannot eliminate those low frequency signals. So we need to consider those low frequency signal as well as one of the sideband frequency are combined together and they are going to be transmitted via the channel. So that is called as vestigial sideband modulation. So the generation and demodulation of VSB can be obtained by this basic block DSPSA modulator and with help of DSP filter. So DSPSA modulator means we can use any balanced modulator. So the outcome of that balanced modulator is going to be double sideband suppressed carrier modulator, because we cannot directly obtain a vestigial sideband modulated waveform. So first we require single sideband, then we have to consider the portion of another sideband. So for everything we need to generate DSPSA modulated waveform. So we require DSPSP modulator, then VSB filter. So this filter is specially designed to allow the required sideband along with the portion of sideband frequency. So this is the transfer function of VSB filter. So as I told earlier, either one of the sideband can be considered. So here this is called as a vestige part. So this part is considered along with the one of sideband. So we have to find out the Fourier transform of vestigial sideband modulated waveform. So for that we have to write the Fourier transform equation for same. So which is equal to AM m of t cos omega ct. This is obtained from the single sideband suppressed carrier. So vestigial sideband can be written as the outcome of this double sideband suppressed carrier modulator with hv of t, that is the impulse function. So AC m of t cos omega t convolution of hv of t. So the convolution of the signal along with DSPSE modulator outcome will produce vestigial sideband. So this is the corresponding equation for this, and we can demodulate the VSB signal by simple multiplier and low pass filter signal. So the outcome of VSB signal is directly given to the multiplier. The another input for this multiplier is a carrier signal. So here also we require a synchronization like our DSB, SE and SSB. So the low pass filter is specially designed to allow one of the sideband frequency along with the vestige part of the signal. So by taking the Fourier transform on both sides of the above equation, which leads to this equation. So the signal x of t is passed through an ideal low pass filter to obtain the outcome y of t. So VSB modulation is successful when the y of t should be proportional to the modulating signal m of t. So it is observed that omega minus 2 omega c and omega plus 2 omega c are the high pass terms, since they represent m of omega translated by plus or minus 2 omega c. These terms are blocked by the low pass filter, which yields an output signal y of t with the Fourier transform of y of omega. So we can write the Fourier transform of the above equation, which gives you this equation. So this is the frequency spectrum curve of VSB signal. We can find out the transmission bandwidth by these equations. So this is the one of the sideband, omega c plus omega m. The vestige part is considered as omega c minus omega v by 2. So if we are obtaining the bandwidth for this leads to omega c by 2. Then we can find out the magnitude response of VSB filter from the above equation. So the magnitude of response of VSB filter is FC plus FV for upper sideband and FC minus FV for lower sideband. So the magnitude is 1 by 2, that is half, and the frequency response of FC minus FV, which is less than h of omega, which is less than FC plus FV, exhibits the odd symmetry. The sum of these two frequency components in the range of FC plus FV is less than F, less than FC plus FV. So this is the frequency range. So it is equivalent to unity, h of F minus FC, that is the transfer function of that frequency leads to 1. So from the above transmission bandwidth curve, we can write h of F minus Fc plus h of F plus Fc is equivalent to 1. This is one thing we have to observe. And second one is the phase response is linear. That is h of F minus Fc plus h of F plus Fc is equal to 1 for the frequency range minus omega to omega, provided the transmission bandwidth of VSB is equivalent to omega plus Fv. So this is the transmission bandwidth curve of vestigial sideband. So we can conclude that vestigial sideband modulation can be obtained by a simple product modulator which multiply the modulating signal with the carrier waveform. First it generates double sideband suppressed carrier modulated waveform. So from DSBSC we are obtaining the single sideband suppressed carrier. After that we are going to use one filter, that filter which is specially designed, which allow only the vestige part and one of the sidebands through the medium while transmission. So from this we can obtain the VSB modulated waveform. Thank you.